Hi everyone. So this video will go along with lesson 1-7 from the Algebra 2 textbook. This will cover like variance and standard deviation. Just so you know, this first part does not come from your notes because we're modifying what we're doing here a little bit. So your notes really focuses a lot on how to calculate standard deviation by hand. We're really just going to focus on the concept of standard deviation and what do we mean when we talk about standard deviation. So I'm going to kind of do some talking ahead of time, and then I will flip over and do an example from your notes. You're welcome to jot any of this stuff down, if you feel like you need to, or you can just follow along. So to back up a little bit before we get into this concept of standard deviation, I want to remind you about something we did earlier in the chapter. Earlier in the chapter, we talked about measures of center, okay? Measures of center is one thing that we're concerned about when we're looking to analyze a data set. And the two biggest ones are the mean and the median. A lot of the times mode gets thrown in here too. I really think that's just a alliteration thing with all the M's. But the mean and the median are two ways that we measure the center of data. And that is an important measurement. That is something that we are concerned about. But like, for example, and let me just move this up here a little bit. These data sets that you have here in front of you, these have the same mean, okay? And you could calculate it if you wanted to, but I will tell you that the mean on each data set is 85, okay? The center of the data set is exactly the same. But you can tell these are very different looking data sets. So there's another calculation that we're concerned about besides mean and median, and that would be measures of spread. Okay, so the two things we often look for with a data set are measures of center and measures of spread. Don't worry, I won't leave those there the whole time. There are a couple of measures of spread that we look at. One of them we've already kind of talked about, I think, is the range. Okay, that measures how far out a data set is spread. And range is just simply the maximum minus the minimum. So it kind of finds the difference between the lowest and the highest, tells you how far or how far your data covers, what kind of spread it covers. Going along with that, we could also use the inner quartile range, which you learned about in the last lesson. Okay, inner quartile range looks at that middle half of the data. So you do Q3 minus Q1. And that tends to be a little more reliable even than the range if you're comparing two data sets as far as like their spread goes, because this focuses on the middle of the data set and doesn't get thrown off so much by outliers, okay? But then the third and probably most common measure of spread is what we're talking about today, and that's standard deviation. And again, there is a way to calculate it by hand. Your notes are designed to kind of walk you through that. I'm going to focus more just on what does the standard deviation mean, and then how do you find it on your calculator, okay? And going along with the standard deviation, there's another measurement we're going to talk about today called the variance. That's a little less significant, but we're going to make sure we talk about it anyway, okay? So this is kind of our focus for today, is we've talked about the measures of center, but now we need to talk about measures of spread, and specifically standard deviation and variance. Okay, so like I said, these two data sets, let's imagine these are test scores, and I think there's 10 points in each data set. No, 12 points in each data set. But I promise you, 85 is the mean for both of them. I worked it out that way, okay? But as you can tell, this data set is spread out a whole lot farther from that 85 than this data set is, okay? If I was going to try to kind of sketch where this data set goes, it does something kind of like this. Whoops, I can't see where my last point is there. Oh, I overshot it or undershot it. So this data spreads out over a long period, where this data does something more like this, okay? So this spread is much larger than this spread. That indicates a higher standard deviation here. When the spread is larger, that means the standard deviation is higher. What the standard deviation does is it looks at the distance from zero that each one of these data points is. I'm sorry, not distance from zero, distance from the center, distance from the mean, okay? So it says, all right, these data points are 3 spaces away from the mean. These are 5 spaces away. This is 10 spaces away. Also goes backwards, so we can say this is 2 spaces away. This is 6 spaces away, and so on, all the way to here. And then it takes all those distances and finds the average. Okay, So the average distance from 0, and then here you would find the average distance from 0. This one, your distances are going to look a lot shorter. Okay, so we don't have any of these large distances like this. All of them are fairly short. And so if I were to find like the average length of that line, that's what's going to give me the standard deviation. So a larger standard deviation means that in general, your data points are spread farther from the center. Okay? Okay, so now I think I'll jump over to your notes page. So you should have a notes page that looks something like this. This is in your notes packet if you happen to have it, but if not, we're going to jump in right here. Okay, so this definition of standard deviation, I'll probably even slide it up a little bit. So standard deviation is the data's average distance from the mean. When we calculate standard deviation and we get a number, that's what we're saying, is on average the data points are that far away from the mean. Now, this part right here is not going to make a whole lot of sense to you right now because we didn't work through the process by hand. But for now, I would make sure you have this jotted down, and then I'll come back and talk about this for a second. So if you look up here to what I have for example 1, I have a data set, and it has you calculating the deviation for each data point. Now, I'm not actually going to do this calculation here, but the deviation, that's the distance from 0. And basically that's found by subtracting the data point minus the mean. So this distance is what's called the deviation. Now, remember when I made this sound really easy? Like all we're going to do is find these distances and take the average of them. We have to do something about the fact that these ones are going backwards. And I would love for us to just do absolute value, right? I would love for us to say, well, this is still 2 spaces away. It's just 2 spaces backwards. So I wouldn't call this a -2. I would just call it a 2. Standard deviation does something a little different than that. And I honestly don't know why. But to get standard deviation, instead of doing absolute value, they take all of those deviations and they square them, okay? And the squaring is intended to make everything positive so that you don't have positive values and negative values canceling themselves out. So instead of just saying, I'm just going to call this 2, they take this positive, what was this one, 3, and this -2, and they square them. So they would call this a 9, and they call this a 4, okay? Then they find the average of those squared deviation values. That right there is the variance, okay? And I say roughly, there is one tiny thing that we change up in our calculation of the variance, but I wouldn't stress about that right now, especially since we're not actually learning how to do it by hand. So the variance is the average of those squared deviation values. Now, that's all fine and good, except when we squared everything and we get that number is kind of meaningless because we squared it. So we're no longer talking about water use. We're no longer talking about cubic meters. We're talking about cubic meters squared. And that doesn't make sense in the context of our original data. So what we do is we take the variance and take the square root of it, and taking the square root undoes all that squaring that we just did and turns it into the standard deviation. So basically just instead of finding absolute value like we did just a second ago, they square everything and then take the square root later. Okay, and that's how they come up with standard deviation. So what you really need to know up here, because your calculator is going to do this for you, your calculator is going to do the standard deviation, it's not going to do the variance. The standard deviation is equal to the square root of the variance, which means the variance can be found by taking the standard deviation and squaring it. So when you find this value in your calculator and I say give me the variance, all you have to do is square it to find the variance. Okay? Okay, hopefully that's making sense. I'm going to talk you through how to do one of these on your calculator, and then I do have a short assignment that you'll do with this, and I guess we'll find out after you do that assignment if it's sinking in or not. Okay, so let's take a look at, oh, that's the same page again. Hold on. Here we go. This example here. Okay, now it says calculate the variance and standard deviation by hand. Again, we're not worried about the by hand piece. I'm just going to focus on this use your calculator step. I might go ahead and do it up here though, just so I'm not sliding the paper back and forth a whole lot. So in our calculator, we want to put this data table in. And I'm going to clear out what I have here. Okay, Now, I have to think about this table, and if I need both these columns of data. This one here is my class period, and this one is the number of students in that class period. This right here is really the data that I'm focused on. I don't care that it's first hour, second hour, third hour, whatever. I want to know what's the average, what's the standard deviation, all that kind of stuff. So I'm going to take this data table only and put it into L1. Okay? And then I'm going to run those one variable statistics just like we've done before. So I'm going to go stat, calc, and option number 1 for one variable stats. Now, on this calculator, because I'm only working with list 1, when this comes up, I'm just going to hit enter. If you have one of the calculators where it gives you like, gosh, I forget what it says, list and then frequency list, I think, make sure that frequency list is blank because you don't have anything put in for L2, or you shouldn't have anything in for L2. Okay, so let's run through remembering what all of these things are telling us. This one here is giving me the mean. So X bar is the mean, that's the average. So on average, I have 25 students per class. Okay? This is the sum of all of them, which actually might be useful information here. I have a total of 125 students. I think this is last year's data, by the way. This one right here is what we really care about. SX, that's your standard deviation. Okay, so standard deviation is 6.2. So we can say that the average of our data is 25. Remember, we said the mean just a second ago was 25. That's X bar. And on average, our data is spread out about 6.2 in either direction. Okay? Now, we can see that there are definitely some that are higher than that and some that are lower than that. But this is on average, this is how far things are spread away from that 25. Okay? Technically, and I'm just going to mention this here, but then I want you to forget about it. This one here, this is a sigma. That's also a measure of standard deviation. For our purposes in this chapter, we're always going to use this one that says SX, but coming up in the next stats chapter where we get into like the introduction to AP stats, we're going to talk about the difference between these two and when to use one versus the other. But for right now, we're just going to focus on SX. Now, if we keep scrolling, this n equals 5 means there were 5 data points, which is a pretty small data set. Remember that down here you can get to that 5-number summary, so your quartiles, your median, minimum, maximum, all of that. You don't see the variance in here anywhere. That's because if you recall, on the previous page I said that the calculator would not give you variance, but all we really have to do is take the standard deviation and square it. So the variance would be like 6.2 squared. Whoops, that is the wrong button, which is 38.44. That is approximately the value you should find if you were to subtract all of these things from the mean, then square those deviations, then find the average. That would be this. The problem is, this thing, this 6.2, we know what this is measuring, right? This is measuring students, because that's what my original data set was measuring. This would be like square students. And what the heck does that mean? I don't know either. So that's why variance is not a super useful tool. It is something you're going to want to be familiar with the terminology. I mean, we talk about it in statistics, but the standard deviation is much more commonly used because the unit actually makes sense. Okay? That's really it for standard deviation. If you can follow those steps in your calculator, again, it's just the same one variable stats that we've been doing, and you're looking for this one that says SX, that'll give you your standard deviation. If you are having trouble with the calculator, please let me know. I'm happy to talk you through it. I did publish a list of some options for you if you don't have a graphing calculator at home. Hopefully those will help you out. Feel free to email me or join in on one of my video conference sessions this week if you need some help. Okay, have a great day.